Hey YouTube, XCT here. This is going to be another video series about pen testing a new lab called Wutai. Just like with Shinra, we are going to go from external to DA in the first domain, and I will leave the rest for you to explore yourself. If you want to try out the labs, check out the links in the description. Alright, so the way this lab starts out is with a short introduction, so let me just read it out. The Wutai group has tasked you with performing a penetration test on its networks. This includes the Wutai parent company and its subsidiary Junon. Wutai is concerned about its security posture since a leak of domain usernames was found online on Pastebin. And then there's a link, and if you go there, you can basically see a long list of usernames on Pastebin. Alright, the goal of this test is to reach Enterprise Administrator in the wutai.vl domain. Wutai employs a small SOC, but its blue team capabilities are still on a rather basic level. Alright, so basically we got these usernames and we have the entry network here. And the first thing I really want to do is just run a port scan. I already did it to save some time, so let's go to this folder here. And then I just did like a normal nmap. I didn't scan all ports, but of course if you have the time, scan all of them, right? And also UDP. In this case, this is enough though. We can see the first two IPs here. They have just SSH open, their infrastructure. You can ignore them. And then there's two more. On 50, we have what appears to be a proxy. And on 100, we seem to have a website. So let's copy these. And then what we want to do is like do a version scan on 8080. Because, well, for the other one, we know it's a website, but maybe there's something interesting with 8080 here. Maybe it can find like a version. And yeah, indeed, it finds that this is actually squid. And if you think about it, that's a bit unusual, right? Why would like a proxy port be open to the outside? Should more be like something you would find in an internal network where clients would then use the proxy to connect to the internet. So this seems to be like a misconfiguration, and we will see how this can be used later on. The other thing is this website we saw, right? So let's just go there and see what we get back. And this is Chasm Workspaces. It says here it's a container streaming platform, and this is exactly what it is. If we go to the website here, we can basically see how this looks like. Let's go from the start here. Basically, you get a couple of apps here and you can just run them in the browser, and then you can get like your Ubuntu machine. Depends a bit on how it's configured, right? You can even like get a Windows desktop. So this is basically like a virtual desktop environment, like you would maybe find with VMware Horizon or Citrix or something like that. It's the same principle. It's just, yeah, basically free up to a certain amount of users. If we would have valid credentials and could log in here, we might be able to get like a machine on the internal network, because that's what it's supposed to do, right? The employees use this, log in here, and then they get like a machine, a Windows machine they can work on. So this would be pretty cool, but we don't have any credentials yet. The other thing is the squid proxy. If this is really reachable from this site and there's no authentication, we might be able to use this to like reach the internal network. And we can do this with proxy chains actually. We set it up like this. We point it to the machine we just identified, which is .50 here, and to the squid port, and then we just say HTTP here instead of SOCKS. And if we do this, we should be able to, if the configuration allows, reach the internal network. Now, we don't really know which IP range the internal network is. So if you don't know, you might have to scan like everything and hope something comes back. Can take a long time. In this case, I already know it, so I don't have to go like the long route. We can just do this IP range. This will be the private one. But like I said, you can just scan everything and you might get it done. And basically now we can scan through this proxy the whole internal network. And you would just do it like this, basically proxy chains, nmap, and then do a TCP connect scan, give it the ports you want to scan, and the range, and it will just work. I'm not going to do that because port scanning through a proxy is very slow. And yeah, it would be annoying to wait. So we already got something here. Let's just do maybe this one and do a grep for open. All right, and this already shows us like the hosts we have on the internal network. We have 50 again, so this also has like an internal interface 100 also exists. And then there's 120, 140, 180, 195, 200, 222, 223. So there are a couple hosts on the internal network. And you can see some of them have like port 80 open, so there might be websites. Some have SSH, some have SMB, so there's a mix of things really on this internal network. And yeah, we want to enumerate that more, right? Let's maybe just do a grep for, let's say, 80 open. This gives us the websites, well, at least the HTTP ones, right? And let's just see if we can reach them and maybe get some insight on what kind of web apps are running there, right? So here we can basically also use this open squid proxy on the external network to reach the internal one directly in the browser via Foxy proxy. So the same thing we did for scanning, we can also do here. So let's just go for all the entries we find here, right? 120 is the first, so let's go there. All right, that's interesting. This seems to be an ESXi server. So this company is using some kind of virtualization. So maybe some of the servers we saw are actually not like physical machines, but are running on this ESXi server. All right, let's go for the other websites. There was one here. Okay, we don't really know what's here. One thing I always want to check is like if it's a default page, if cert server is here. Because if it is, it's maybe an Active Directory certificate service server. But it's not the case here. There was also this IP. This is asking for authentication, so we can't really do anything. There was also 200, I believe. We don't get anything back here. Okay. That's not too useful. Also a default page, so let's again try to check for cert serve. It's not here. Oh, I also typoed it, right? Should be. Oh yeah, it exists actually. So this is likely an ADCS server because in this path it's asking for authentication. And then I believe there was one more, which is this one. Okay, it's redirecting us to SSL. And also like to a specific host name here, right? This is the point where you have to add it to your hosts file to be able to reach it, because we don't have DNS resolution into the internal network, right? I already did that though, so I don't have to do it again. And accept. And this is also pretty interesting. There seems to be a Bitwarden password manager server in use. So the users are likely storing their credentials, which they need for whatever, in this Bitwarden instance. So if you can like get access to this one, that would be great, right? Okay. The same we can basically do for 443 here. Sorry, like this. But you can see it's like the same IPs we just got, right? We checked all of them already, so we don't really have to do that like again. So what other enumeration steps can we take without actually having credentials? Well, one thing we can do is we can run crackmap exec through squid and just run it without any parameters in SMB. And this will actually connect to SMB on machines it finds and will like get us some information like what's the domain name, what's the machine name, which can be pretty useful in this situation. All right, so there's like 4 machines here found. From the port scan, we can now like map which one of them is the domain controller, right? And if you look at the ports, you'll see that this one is actually the DC. And then the next thing we can do is essentially exactly the same command, just with SSH. And this will give us like a few SSH versions. Maybe that could help if there's like one that's particularly old, but in this case doesn't really help, right? They're all pretty recent, so. But it's still like interesting to know which of the machines have SSH. So it's either a Linux machine or someone installed an SSH server on a Windows box. All right. What else can we do? One thing is to check for anonymous or null authentication. It's the SMB command again, just with like an empty user, empty password, and then we do shares. And if the authentication would work, it could actually enumerate the shares on the Windows machines. And this kind of suggests that it worked to authenticate, but you can see that it can't enumerate the shares, so that just doesn't work, right? Okay. Basically, one other thing we can do, besides like looking more at the port scan and looking at apps that might be exploitable, is to check for AES rep roasting. Remember in the leak, we had like a huge long list of usernames. And if one of them would have like the checkbox for doesn't require pre-authentication, we might be able to get a password hash by using AES rep roasting. So we have this users.txt file here. You can just tail it. And the format is like exactly like in the leak. But we want to clean it up so it's just the name in front. So we can just do like a cut here and then we like split it on the edge, only keep the first part. Looks like this, right? And then we do users clean.txt and save them. And this is now usernames that we can actually use in the AES rep roast attack. So let's put them here through proxy chains, of course, LDAP. We give it the IP of the domain controller, and we know from the port scan that like where 88 is open, that's likely the domain controller, right? Then we just run it. Yeah, but you can see there's like no results, so that's also dead end. Okay, so at this point, we basically want to have credentials to continue enumerating, to continue maybe logging into the virtual desktop environment. So how can we get credentials? Well, we have a long list of usernames, and really good thing you can do now is basically spray passwords. What kind of password you want to spray really depends on the company and what you basically guess they could have, right? Simple things are always like season and year, or like company name and year. And I know you don't have unlimited attempts, it might be detected and so on, but it's really still a good way to like get a foothold into the network. So in this case, I'm just going with season and year here. So do summer 2023. And then we use crackmap exec once again to spray through the squid proxy. This is the IP of the domain controller. This is the username list. And we spray the password here, summer 2023, against all users. And yeah, we also do continue on success because we really want to get all of them. Because maybe we get one that has like completely different permissions from another user, right? So there's already a hit here. That's great. Let's see if we can maybe get a few more users. And there's another one. And another one. Can we get one more? Yep, there is another one. And now that we have credentials, we can basically like run Bloodhound or something like that and check out which kind of permissions these users have, right? Maybe they don't all like have the same permission set. Other things to try would be stuff like Wutai 2023 and Unon 2023, because Wutai is like the parent company name and Unon is like the child company name. But I'll leave that to you if you want to try it out. You might get a few hits on these two, and then you can like check what kind of permissions these users actually have. All right, I'm just going to abort this here to not like bore you. And now that we have credentials, we can basically try to use them. Either on the virtual desktop environment or like logging in via squid somewhere on the network, right? There's just one more thing I want to show you. So there's actually a seam running in this network, just like in Shinra. And we can see basically a big spike here, and this is our brute forcing attempt. So you can directly see like in the default dashboard that there are a couple of authentication failures here. Like I said, this doesn't necessarily mean that the person checking this is thinking this is malicious. Could also be like just a service misbehaving or something like that. But well, keep in mind that this actually shows up and someone might have a look at it. So like it's a good technique to know and to execute if you can't get a user otherwise, but still be careful to like not overdo it. That's all I'm saying. Also, like I'm going to show this through the video series a bit more often to like just show you how things are getting detected. So now that we got a couple of users, let's actually try to log into Cousin. So let's take this one, Terry Low, and we add the work.unon.vl, and then just summer 2023. And we see that it works. And there seems to be exactly one app here, which is Unon Virtual Desktop. So let's start that one, like this. And we have to log in again. So let's just do this one more time. And summer 2023. All right, this actually worked and we got a remote desktop connection. Let's get some situational awareness here. So we are on S21M10, okay. IP-wise, this is the 180 machine we saw earlier. So you see that the machine we logged into, which was 100, is basically just like a proxy that allows us to RDP here to 180, which is completely in the internal network, right? This machine doesn't have any like second interface on the external. This is a completely internal machine. And we have to use the virtual desktop environment to access it. All right, so let's do a who am I all to like just see if there are any interesting groups. We are remote desktop users. Guess that makes sense because how else would we connect here? We are in the remote group. Okay, that's probably what gives us the remote desktop users. And other than that, doesn't really look like we have any special permissions. We can do an echo logon server to like see what the domain controller is. And that's S21M5. And we saw this one earlier as well, that it was the like .200 domain, right? If we do like this, yeah, you can see it. This is the IP of the domain controller, but we already know that, right? Then let's like check if our user can do anything special if we check it with net user. Okay, no comment. Password last set is all not too interesting for us. This is pretty interesting, I think. So home directories in this environment are actually on a central file server. Let's actually go there. Check out our home folder. Well, for once it's like mounted here. That's also why we are in Z here and not in C. And if we go like here, we can actually access that from the file server. Let's just go one back. And you can see that every user has a home directory here. But usually we shouldn't like be able to access the other ones, right? But if you go here, you can see that actually there doesn't seem to be any like file permissions that would prevent it. So let's delete that again. This is interesting. So we can basically access all users' home folder. So we found the vulnerability here. Let's actually go for text files here. And you can see that there's a flag here. So that's one way to get one of the first flags. And also a thing that sometimes happens. The other flag is like, if you get access here, there's a user flag on C. So at this point, you already have two flags. Just by like doing the spraying, grabbing this one, and then snooping through the shares and basically finding the flag there. All right, so let's see if there are any other shares on this machine, right? It seems to be a file server. Might as well have some other shares. And yeah, there are a couple of shares here actually. Homes we just checked out. Then there's IT. You can like go through all the folders if you want to, but they're pretty empty here. All right. What about manage engine? This is interesting. There's a config file, so let's edit it. And there seem to be some kind of credentials here. This seems interesting. There's a username. And there's also like something that looks like a password, but like it doesn't really look like a normal password, right? So it must be some kind of hash or encryption or something like that. So let's just save that here. Actually, if we want to like confirm, we can, I guess, just do net user svcme domain. And you can see that's actually the manage engine admin account. Okay, that's pretty interesting. Even though the domain user doesn't really have any special permissions, since this is the admin account, maybe this password of this account is like the one that can log into manage engine itself, right? If we find it like on the network running somewhere. So that's pretty interesting. What else do we have? There's transfer, but it's also pretty empty. And these three folders are all related to WSUS, which is the Windows Server Update Service. So this machine or some machines on the network are likely like getting updates from a central server. All right. There's one more thing we can actually do here, because here it doesn't show any hidden shares. So the way to check this with Windows, we can just do like netview, and then we give it the machine name and the /all, and we should get all the shares. Okay, this was the domain controller, I'm sorry. It should be 15. And you can see that there are some shares here that end in a $, and these are hidden shares. So they aren't shown here, but if we like just go to them, because we now know that they exist, we can actually like get to them. So it's just a visual thing here, right? It's not really a protection anyway. All right, and there's a program here called Secure Pass. This is also pretty interesting. We could like, let's see what this is actually doing. Because we kind of have the suspicion, right? Secure Pass, maybe this SP, Secure Pass, this was generated with this program. So maybe we will be able to reverse it somehow. Let's actually just run it here to see what it's doing. Okay, it wants a password, so let's just give it test. And yeah, this confirms it, right? We gave it a password and we get some kind of hash or encryption or something like that. And let's just run this again. And now it changes. So there seems to be like a random or a time-based component. So this will be interesting. We're going to save that binary, of course, and then later on in one of the other videos, we're going to analyze it. But we're not going to do it right now. Another thing that's kind of suspicious is that it's saying Linux here. This is also not like very common. And this means basically that WSL is installed. So can we actually like run Ubuntu or something like that? Let's see. Yeah, this actually exists. So let's try to run it, but yeah, it's not working. And the reason is that normally like to start Ubuntu or WSL, WSL2 specifically, you need administrator permissions, and we're not an administrator, so we can't run it at this point, but maybe we can go back later to this, right? All right, let's also like explore the file system a bit to get a better overview. All right, there's inetpub here, so this is a web server, right? There doesn't seem to be a whole lot here, but one thing I always check, like on every machine, is if we can write here. And in this case, we actually can. And you might think this is a bit far-fetched or something, but this is so valuable if you can actually write there that I think it's a good like practice to always check, because if we can write here, we can in theory just place a web shell and then escalate via scimpersonate and actually root the box. So this is like something I always want to check. Other than that, let's see, install. No, it's empty. Temp seems empty too. What else is there? Users is always interesting. We can see that the domain admin was actually logged in here. So if you can like escalate privileges, maybe there are files in his home folder, right? Could be. There's a VDI user. Yeah, but we don't have access to anything here, right? And it's just like to get an overview what users exist. Also always like show hidden items, and let's check out program data. And here we can see that Avira is installed as an AV. So if you want to like get a beacon on the machine, keep in mind that it's not Defender, it's Avira. And you can install it in your local VM and develop the payload against that, right? SSH, okay, that's empty. Yeah, and we already got a pretty good overview on like where we are, how this environment looks and all of that. One other thing I want to like check is I want to check for system proxies. So what we can do is basically system.net.webproxy get default proxy. And this will show us if there is basically a proxy running. And you can see that this is indeed the case on this machine. And we suspected this because we saw the squid already, right? We already used it. So The users on this machine are basically supposed to use the proxy server to connect to like outside the internet, whatever, right? And the only like URLs that can bypass it are basically like Microsoft and HTML, whatever that is. And also like in this case, we could also like try to enumerate the firewall, because if the proxy is set here, right, it totally makes sense that other connections to the outside world are not allowed. I'm not going to do like a full like check now, but what you can do is basically port scan your own machine, for example, or some other endpoint you control, and just see if any of the traffic is actually landing on your machine. And I can tell you in this case, it's not the case. The only thing you can really do to leave this machine is communicate via this proxy. And this has some unique challenges later on when we develop a payload in the next video. Alright, so I'm leaving the virtual desktop environment for a bit, because we can also use the credentials from Linux to enumerate further. And there are certain advantages to this. The first thing I want to do is run Bloodhound. And if you ask yourself, why not just run it on Windows? We got perfectly fine access. Well, that's true, but you would have to either obfuscate it to bypass the AV or get a beacon first that bypasses Avera that you can then run Bloodhound or Sharphound with execute assembly. And we don't have that yet. And I will do that in a later video. So let's just run it from here instead. And this should be working perfectly fine. It's the same user credentials here, right? We use, that's actually important if you want to do it. You want to point it to the DC as a name server, but you want to do TCP because the squid doesn't like tunnel UDP for us. And also like you want to generate a zip or get a couple of single files, which is a bit annoying. All right, then we can upload it here. And now we can actually like check our user that we got, which is Terry Lower. Okay. We get a couple of information here that's actually important for us. Like this, a couple of things we already saw, like where the home directory is, what groups he's in. He's actually in domain users and remote, like we saw before. But he doesn't seem to have like any special permissions. Yeah, I can't see like any special permissions right now. And at this point you can like enumerate all the stuff in the Active Directory. You can see there are about 200 users here, a couple of groups. Doesn't seem to like have certificate templates or CA, or maybe it just wasn't collected. No Azure here. Okay, so I'm not going to go like through like Bloodhound for a long time here. Just quick overview. Got a couple of domain admins here. That's already a bit interesting, right? You can see the domain admins have a prefix which is DOM. So this seems to be a tiered administrator model in this company. And maybe there are other administrator tiers as well. Domain trusts are also always interesting. We can see there's EU and work, which is both in unon.vl. And they have bidirectional trust. So likely there will be later on some way to move from work to EU, right? Otherwise you can just like click through all the stuff, right? Who can DC sync? Let's see. Jay Griffin, that's a normal user. That's suspicious. The password audit group administrator, of course, the domain admins, sure, and the DC too. So yeah, you can get some nice information here. Cabarostable accounts, well, not really anything here, right? SREP roast we already checked, but there wasn't anything there. Yeah, and you can basically just check all of these points and get a good overview. But let's just leave it at that for now. Other things we can do here from Linux pretty well is, for example, enumerate the domain shares. The same thing we basically did manually, we can also do like with crackmap.exec here. And yeah, the advantage is that basically you can do it from Linux, and if you don't have like VDI or something like that, that's a good way to do it. Okay, that's one server. That seems to be the domain controller. And here's the server that we just manually enumerated. And you can see that crackmap.exec is directly displaying the hidden shares, so you don't really have the issue here. All right, so the next thing we're going to check is signing. So we're going to look for machines that have SMB signing disabled. And if that's the case and you have the chance to somehow relay authentication, you might be able to get onto those machines in some kind of way. So let's just run that as well, just to get a bigger picture. And while this is running, I'm also going to check the machine account quota. I'm just going to do this down here because I don't want to wait for the result. Okay, the machine account quota is 10, that's the default in domains. So if there would be like a scenario where we want to create a machine, like resource-based constraint delegation, we could just do it. Also for the signing, we can see that these two have signing enabled. So these are probably both domain controllers. I would guess this is the one for EU and this is the one for work. But there are also like servers here or workstations, well, more likely servers, that have signing disabled. So if we can relay somehow, we might get access to these. Also, we can see like the build version here. It's telling us it's Windows 10, but it's actually like from the build number, a very, very recent version. So it's actually server 2022 everywhere. All right. What else can we check? Well, you can check like for vulnerabilities like zero logon, petit potam, no pack. That can basically do that. There are modules for that. So check out the documentation if you want to do that. In this case, it's not going to yield anything, so I'm not really running it. One other thing I want to run though is check for ADCS. And yeah, that doesn't seem to be a CA in this domain. Okay, so what else can we do really? Well, one last thing I always do, and this is really useful, is to check if we can log into SSH with our domain user. The reason being is that if Linux machines get joined to the domain, the default setting is basically that every user can SSH there. And like if you find a privilege, that's really good, right? You can just SSH to a random box, escalate privileges, and if it's domain joined, and go from there and maybe escalate further. So it's always like a really, really useful thing to check if domain users can log into Linux machines. Okay, that's it for the initial enumeration and first video. In the next one, we're going to develop a loader that bypasses the AV so we can get a sliver beacon onto the target. And as you saw, we have on the one hand have to deal with Avira. On the other hand, we have to like get around the fact that there's a web proxy and probably all other traffic is blocked. So I hope you enjoyed this video and see you in the next one.